Hello everyone and welcome back to our part 3 of the ChatGPT series. So just to recap, in our last episodes we had two parts. So it was in part 1 we did the conversion from just the Shakespeare model to an actual ChatGPT model that can talk. So we taught the model to understand the roles in a conversation. As I said, there were 3 roles: the system, the user, and the assistant. So the user is us and the assistant will be the model, and the system is just the environment itself. So, and in part 2 we set up the tokenizer, we added the command prompts for the chat model so we can use it in the terminal, and we also set up the main training pipeline for the ChatGPT model. So all of this has led us to this moment. So today we're finally going to train the GPT model and make it talk. So I'll just show you guys how to do everything from scratch, from opening the project and all the way to chatting with our model. So if you guys are ready, let's go ahead and begin. So what we need to do first is open up our PowerShell or the terminal, and you just need to locate your file where you have been coding all this time. So it will be the LLM project. We have named the LLM project, but you can just find your file. And when you do that, we go to that file directory. So it will be cd and LLM project or whatever your file is named. Then once we have that open, we need to activate the virtual environment. So in order to do that, we'll type out dot dash vmv dot slash scripts activate. We'll do ps1. Okay, so you can see the virtual environment here, the .vmv at the beginning of the line, which means that our virtual environment is now active. So you can also check your Python version. So it doesn't matter really, as long as it's Python 3.12 or the latest one or any other closed versions, then it should be fine. So now the first step is to train our sentence piece tokenizer on the language dataset, right? So we gave it Shakespeare when we were doing the Shakespeare series, and in our last episode we specified a normal English language dataset, but you can do any dataset you want to install. You can find it from Hugging Face or just from the English dictionary. You can just find the language dataset and install it on your model. And basically what you do is just take it and put it in your data file that we have specified in the last episode. We can quickly do this part again from the terminal this time, so you guys can see the full process. So what we do is write Python TinyGPT.py train tokenizer. It will be input data / raw / input.txt, and we'll say for now vocab size, let's say 8,000. Okay, so you wait a bit, it will take a couple minutes, and we'll be back when we're done training the tokenizer. And there we go. We now have our tokenizer saved as tokenizer. You can see here sp.model, and the vocabulary will be allocated to tokenizer sp.vocabulary. So basically what we did here was this will build a custom tokenizer which will scan the datasets that we have imported. It will find the common patterns with the words and create a vocabulary of 8,000 tokens in our case that the GPT model will use internally. So it can be a higher vocabulary, but for the purpose of simplicity, we will use 8,000 words. And next, what we have to do is we need to convert the raw text into token IDs and then split them into train and validation sets. So we did this in our last series, but we'll do it again once I say. So let's go ahead and write out Python TinyGPT.py preprocess input data slash raw slash input dot txt sp model tokenizer slash sp dot model output the data processed and to process to corpus idz. Actually, it should be corpus IDs dot idz. Okay. So once again, this will also take a couple minutes and it will look different to what we just did since it won't really make any outputs while processing. So if you just wait a couple minutes, it will say okay and we can continue. And while it's loading, I just want to explain real quickly that what this step does is that it encodes the entire data set with our tokenizer and it will store it into a compressed MPZ file. And this file will be used by our training loop so that the model can read efficiently. Because as we said, the model can only read token IDs. It doesn't actually read the words we say, but it rather converts them into tokens and reads them, then gives us back an answer in the tokens. But our encoder, or the decoder actually, in this case, our decoder will convert these token IDs back to words so that we humans can understand it. So we can go ahead and we can remove our previous checkpoint so we can start fresh. So I have already removed it, so it will show me like this, but for you guys, once you run this command, it should just continue without anything else. Now we'll just quickly run the pre-train step for our model. So we don't want to spend hours waiting for the CPU to pre-train. So just for keeping it simple for this video, I will be running it on a small pre-training step, which will just initialize the weights. It will run one optimization step on the token prediction, and this should be enough for our fine-tuning demonstration. So let's go ahead and write out Python TinyGPT.py pretrain data, then we'll put data slash processed slash corpus IDs dot mpz. Then we'll put our SP model so it will be tokenizer slash sp.model, and the max steps, as I said, it will be just one, just for this video. But you can change this according to your preference and whether your machine can handle it. The higher max steps would mean the model performs better, but it will consume more resources. So once we run that, you guys should see a progress bar that should fill up instantly. So basically, this is using the architecture we coded in part 1 and part 2, where we did the embeddings, we did the multi-head attention, we did the feed forward layers and everything. So once we see the checkpoints saved to checkpoints, the confirmation that our command worked, now comes the fun part. Now it's time to chat fine-tune on our data. So basically we're going to fine-tune our model on a small chat dataset I prepared, and each example will teach the model how to accurately identify its role in the conversation and respond accordingly. Basically, it's teaching it how to behave like a helpful assistant. So we just need to write down Python TinyGPT.py sft chat JSONL, then data slash sft slash clean chat JSONL, sp model tokenizer slash sp.model. Then we should set the checkpoint. So checkpoint, it will be checkpoint slash tinygpt.pt. And the max steps, a small number actually, is 400. Usually, if you want to have a decent one, it should be at least, at the bare minimum, at 1000 or 2000. If you have especially a large data set, but since we're working with a smaller data set here, 400 should be okay. Okay, so we should see a progress bar now. Oh, and seems we got an error, but that's fine. It was just a typo. So basically all you have to do is just copy this new line I've written. Since the difference here would be that we have written the checkpoint twice in the first one. So we have to do double dash checkpoint, then checkpoint slash tinygpt.pt. But here we had two checkpoints by mistake, .rm and checkpoints. Since we made a typo here, you can just delete this and do double dash checkpoint, checkpoint slash tinygpt.pt. Max steps 400. So once we run it, we should see the bar again. So for the 400 is the max steps we defined here. And as you guys can notice, over here, the loss is going down, right? Because it's going down because it's learning to respond to things like hello, what is Python, what's machine learning, and so on. So it's just learning to, it's training itself actually to answer better to our questions. So as you guys can see, it started from around 5, now it's already below 1. And that's actually a good sign, especially when you're training the GPT model. The loss should be going down. Otherwise, there's no progress. Okay, so now that the fine-tuning is finished, as you guys can see, our loss here, 0.016. Keep in mind it started from around 5. So that's actually huge. I mean, that's actually supposed to happen when you're training the models. They should keep going down. Otherwise, the model will not be training. So, since we have finished our fine-tuning, what we have done is we have updated our weights. They are saved back into the checkpoint slash TinyGPT, the file we indicated over here. So now, the part we have all been waiting for, let's talk to our model. So let's launch the chat mode we wrote earlier. So let's go and write out Python tinygpt.py chat checkpoint slash tinygpt.pt. Then we have the sp model tokenizer slash sp model. Then we have to now define the system, the environment. So system, we'll say you are TinyGPT, a helpful assistant. Okay. So this should load up our environment now for the system. And as you guys can see, it says type exit to quit and you. So this means it's our turn to give the model a prompt. So we can just try some prompts here. For example, we'll say hello. And as you guys can see, the model should answer with our greeting. So it should say, Hello, how can I help you today? So nice. This means that our GPT model is alive, that our transformer is replying to us. So we can also just ask some more questions. For example, what is Python? Python is a popular and beginner-friendly programming language used for AI, data science, and automation. See, this is the exact kind of beginner-friendly explanation that we wanted from this model. And now let's ask, what is machine learning? Machine learning teaches computers to learn from data and make predictions without being explicitly programmed. So this is a slightly more advanced question, and as you guys can see, it can also explain core concepts like machine learning using the patterns it saw in our fine-tuning data. So let's ask some more basic questions now. For example, who are you? I am TinyGPT, a small transformer model trained to be helpful. So perfect. So it identifies itself as TinyGPT and stays in character as a helpful assistant. So after checking these examples, if you want to quit the chat, basically all you have to do is type in exit. And there we have it. We have just seen and spoken with our GPT model that we have created. So that's actually pretty much it for this episode. Since we trained our tokenizer on the dataset, we pre-processed the text into tokens, we ran the pre-training step, we fine-tuned our model on a custom chat dataset, and finally we actually talked to it with our own transformer model. So we actually talked to it and got replies back based on our prompts. So if you have watched from part 1, you have now seen the full journey from architectural to setting up the pipeline to training it to an actual mini assistant running on our laptop. So if you want a part 4 where we scale this up, we can maybe benchmark it or try to add reasoning behind the tasks. Let me know in the comments below. And thanks for watching, and I'll see you guys in the next one.